Good morning, everybody. Today we are going to see transverse wave. Now, what is mean by transverse wave? A transverse wave is nothing but a wave in which the particle of the medium vibrates in a manner, that is a direction which is perpendicular to the propagation of wave. So here, when we consider it as the direction perpendicular to the direction of propagation means what? The traveling of the direction of the wave is called as the propagation, and under such a situation we say that this wave is a transverse wave. Now, if you want to give the example for this, then we call that as a water wave. Now, you see that when you drop a stone in the water of tank, you find that the ripples starts moving in the direction outward. That point at which the stone or the pebble is being dropped, that becomes the center, and from there onwards it travels in the direction which is called as the propagation of wave. But the vibrations are said to be perpendicular, means up and down it will be when the wave is moving in the front direction. Hence we term it as a transverse wave. Now, what are the characteristics of this transverse wave? If you look here, all the particle in the medium in the path of wave vibrates in a direction perpendicular to the direction of propagation of wave with same period and amplitude. There will be no different period. It will remain consistent. Amplitude variation will also remain same. It will not be less or more. So hence, first characteristics which we have seen, that while vibrating, the direction of the propagation of the wave have the same period and amplitude. Now, one second condition, if you look here, you will come to know that when the transverse wave passes through the medium, it is just divided into alternate crest and trough. Alternate crest and alternate trough. The upper part is called as the crest and the lower part of the wave is called as the trough. So, you will not have the crest after crest, trough after trough, but alternatively crest and trough will be seen. So, a crest and the adjacent trough forms the one cycle of the transverse wave. Means if we see the graph, we come to know that from the origin, if it starts and forms a crest. It again comes down, the wave comes down at the origin, and then it goes to the minimum value, that we call it as a trough. This trough and crest forms one cycle of the transverse wave. Now, crest and trough is responsible for the transfer of energy. Crest and trough they play an important role, and their role is to transfer the energy, because you see that at the seashore, on the sea, we find that the water is having the same transverse wave. It comes at the shore, and when it comes on the shore, and if we are standing there in the water hits our legs. This means that we feel the sensation of hitting of the water on my foot or my legs, and this means that energy is transferred from that water to our body. So the reason is due to this crest and trough. Next is that transverse wave can travel through solid and transverse wave can travel through the solid and also liquid. Means here transverse wave need a medium, and that medium, he says that it can use solid as well as liquid. When transverse wave advances through a medium, there is no change in the pressure and density at any point of the medium. Now, what is the main criteria to be observed? Here we say that transverse wave advances through a medium, means when it is traveling, when it is propagating through the medium, it is expected that the pressure should not change and density also should not change at any point of the medium. Otherwise, then it is the failure of that wave. So hence we have to note that change in the pressure and density should not take place at any point of the medium while this wave is propagating. Now, if vibration of all the particles are constant in a single plane, what happens? Then we call that wave as a polarized wave. Now you see that polarization means what? We know that the sunlight which is coming directly onto our eyes or retina, that time we find that we get a bright light on our pupil of the eye, and we get irritation due to the continuous fall of light. So the reason is that it is unpolarized light. If I want my eyes to remain safe, I have to take precaution that I should use the lens which is doing the duty of polarization. Here what is meant by polarization? Polarization is nothing but only the vibrations of the wave which are coming from the sunlight, only in one plane those vibrations should be there, so that it does not affect our eyes. Similarly, here also, when I say that the vibrations are constrained in a single plane, what I said, vibration of all the particles. If the vibration remains in one plane, xy plane, that time we say that the wave is a polarized wave. So this was all about the transverse wave. Now we are going to see the longitudinal wave. In case of longitudinal wave, only we have to focus upon the vibration of the particles. Now you see here, it is said that it is the longitudinal wave is the wave in which particle of the medium vibrates in a direction parallel to the direction of propagation of wave. That is called as the longitudinal wave. Now I will give us somewhat example relating to the longitudinal. Now you know that the railway is moving and every bogie is being connected to each other. So when the engine applies the brake, that time the joint which has been there in between the bogie and that railway engine, sometimes they get compressed, sometimes they get rarefication. Means there is a possibility that the action will take place like a spring. Sometimes it will be pulled out, sometimes it will be compressed. So this happening takes place when the wave is propagating. And if such an event takes place, then such a wave is called as the longitudinal wave. So how we define that longitudinal wave? Longitudinal wave is a wave in which the particle of the medium vibrates in a direction parallel to the direction of propagation of wave is called as the longitudinal wave. It is very simple. If you compare transverse wave and longitudinal wave, you come to know that transverse wave vibrations are perpendicular to the direction of propagation of wave. In case of longitudinal wave, the vibrations of the particles are parallel to the propagation of wave. Now we are going to see the characteristics of longitudinal waves. Here, when we want to consider the characteristics, again the thing is that all the particles of the medium along the path of the wave vibrates, but in which direction? Parallel to the direction of propagation of wave. This is the basic characteristics. We have to mention it. While doing so, here one thing is to be kept in mind, that the same period and amplitude should remain there. There should be no change in amplitude and period. So for one complete cycle, if you take 1 second, then for every cycle the period should be 1 second. If the amplitude is of suppose 1 centimeter, then in every wave forming a longitudinal wave, the periods that amplitude should remain same. Now third is that when longitudinal wave passes through the medium, here the medium is divided alternatively into compression and rarefication. Compression and rarefication means what? A simple example I will give you is that, you know the spring in the pen. That spring, when you apply the pressure to both the faces of that spring, you will find that the spring distance between the successive rings, it is found to be very close. That we term as compression. But if I apply my force on both the faces externally, you find that now the successive rings are displaced away from each other. And when they are displaced away from each other, we say that it is called as a rarefication. In tuning fork resonance experiment, there also we are using a tuning fork which provides us this rarefication and compression. So a compression and adjacent rarefication forms one cycle. What we have seen? We have seen that in transverse wave, one crest with one trough form one cycle. But in this case, here instead of crest I will speak about one compression, and instead of trough I will speak about rarefication. So the adjacent compression and rarefication gives us one complete cycle. So this is the condition. Now if you look, longitudinal wave travels through solid, liquid and gases. Now there in transverse wave we have seen that it travels through solid and liquid only. But here longitudinal wave is said to be traveling in all the three states: solid, liquid and gases. Compression and rarefication is responsible for the transfer of energy. Correct. Now, you know it very well that if you compress it, you need energy, means you have to transfer the energy. When you rarefy that wave, rarefication, that time also there is a transfer of energy. Means in both the condition of rarefication and compression, a transfer of energy takes place. Okay. Now when longitudinal wave advances through a medium, there is a periodic change in pressure and density along the path of the wave with time. Now here what he says. Here he says that there will be a periodic change in pressure, and when there is a periodic change in pressure and density, then that wave will be nothing but longitudinal wave. And hence it is said that in the previous condition we said that there will be no change in the pressure and density. Now I am speaking here, there will be a change in pressure and density along the path of the wave with time. Means time is also one of the main factor. Depending upon the time, these changes will take place. Now, longitudinal waves cannot be polarized as the direction of vibration of political and direction of propagation of are same. Now here what you want to say is that longitudinal waves cannot be polarized because the direction of vibration of the wave is parallel to the propagation, and hence it cannot get polarized. So this is one of the reason. So today we will stop here, and in the next lecture we are going to see the next article regarding